All right, we're going to start by looking at Unit 7 calendar. I started kind of propagating out into third trimester. I'm kind of admitting that there will be something next week now. And I need just a little bit of thought from you as we go through that. So I'm going to put it up here so you can take a look. So this is Unit 7. This is what we've been doing since the middle of February, which has just been kind of going and doing its thing. We did Newton's first law, Newton's second law. Now we did some kinematics in there. So we are right here now at the Rotational Inertia Lab, and we're finishing that up today. Friday, we're going to do rotational kinetic energy. Then we have a 3-day weekend, or you have a 3-day weekend, lucky you. Tuesday, we're going to do angular momentum and its conservation. Wednesday, I'm going to be gone, but I will set up and I'll show you what the applied problem will look like that you'll do on Wednesday while I'm gone. So it won't be like a big mystery, but it's something that you can do without me having to be answering questions all the time, okay? Then we're going to review, and then we are on track to take a test over Unit 7 a week from tomorrow, okay? So that's kind of where we're at. Is that making sense to everybody? Question?
What did you say the right of
I don't remember, but we can look in just a second. Is that okay? Yeah, let me pull that up in just a second. Go ahead, Jonathan. Here, let's look right now, because then we can just know. We had said, oops, that's not what you wanted. Where did it go? Didn't I have it in here? Torque and rotation lab? I don't even know. I'll look in just a second, unless it's, oh, there it is. Is that it? Dun-da-da! Okay, just got to look down further. So, okay. Shh. One thing at a time. So, we're going to talk about the analysis. That's the first thing we're going to do after we talk about the calendar stuff, okay? The Google Sheets spreadsheet is due by the end of the day on Tuesday, okay? So that gives you all weekend. That gives you all of Tuesday as well to discuss if you need to. And I only need one per group. That doesn't mean pick the kid that likes Google Sheets the most and have them do it, because you're all responsible for it. And if that kid's good at Google Sheets but isn't good at this, then you all are owning that, right? So I want to make sure that you all understand it, okay? But I also don't want to grade that many Google Sheets because it's not worth it. What I am going to grade for you, let me finish and then I'll answer your question. Is that okay, Isaac?
Yeah.
Okay, so what I am going to grade individually is a conclusion evaluation section. So the very first day that I met you, so long ago, remember we had that rubric, right? It was like the design, data analysis and processing, conclusion evaluation. So each of you has the opportunity to write the conclusion evaluation section for this lab. After you've done the analysis, you can't write it yet because you don't know how you did. You haven't even taken the data yet, right? But once you do that, this will be due that day by 11:59 again. So if you don't have time to do it until after school next Friday, that's okay, because you're just going to give it to me on a Google Doc by next Friday after, like, not at midnight, okay? Does that answer your question? Okay. Isaac, you had a question a minute ago. What was your question? Wonderful. Okay. So back to the calendar and the kind of where that leads us. Oops. Today's the last day of February. Happy end of February. We are back to March. So, friends, I'd really like your attention so you don't have to ask me this later, and also so you can be a part of the conversation. So we're going to take a test here on the 8th, okay? That's when we're going to finish Unit 7. Sounds all right, I hope. We have spring break here, so no school, which means we've got a week between that test and spring break. And during that time, at some point, I would like for you to take your final from trimester 2, right? Like this practice, we have to get our brains back. What I need to know, and you don't have to tell me today, but I want you to think about it, is when would be the best to do that final. I'm thinking it'll be 2 days. I haven't really, this is the first that I'm really kind of articulating it, but I'd like to do probably 2 days, and then I'll introduce some new material. So we could either, review, test, or we could do a little new stuff and review, and then review, test. I don't know what is the best in your heads and based on the rest of what you have going on. And if you're, leaving for sunny California on the 13th, then you need to let me know that, right? So that I can we can plan around that and that sort of thing. Because I want everybody to have that final done before I leave for spring break. Yeah.
Yeah, I said we do it like right away.
Like,
For you right now? That's text.
I don't have it for you right now, but you mean like to do it early in the week? Is that what you're advocating for?
That's Tuesday.
Tuesday, Wednesday?
Yeah.
It's easier to have tests on full days than on Thursdays, typically.
Well, so Tuesday, Wednesday, Thursdays are all the same length.
So you can have it on Monday and Friday.
could spill over into Liberty time if we don't finish.
Maybe. Yeah. Yeah. So I guess because I can write it for the like I can adjust questions, right? So really what I'm looking for is like when in the week do you prefer? And I really don't care. Henry, go ahead.
So if we take it earlier in the week, what are we gonna do the remaining days before?
We're going to start the new unit.
But aren't you worried we'll forget it?
I am absolutely not worried. And we don't have time because your AP test is like here, right? Like it's not very many weeks after we get back from spring break. So we don't have time to waste days. Yeah, it's coming soon.
What do we do after?
Stuff, physics. We'll talk about that later, not right now. Go. We don't have time to waste because we got to do our lab today. Go.
I think we should do Tuesday, Wednesday, as Monday will give us a day for review.
Okay.
And Thursday, Friday, a lot of people leave early for spring break.
Okay, so you'll miss a lab that you'll have to make up when you get back from spring break, but we can make that work. So you're kind of thinking Tuesday, Wednesday, the 12th and 13th?
Yes, ma'am.
How does that feel to people? Does that sound okay?
Yes.
Okay, that's what I will plan on in big air quotes, but we'll see what we can do. Okay? What I would like you to do right now is to get into your groups, but you're going to all get paper out, and we're going to talk about this analysis for like 5 minutes. Okay? So get into your groups right now. The lab analysis that you worked on yesterday and struggled with a lot. And by that, I mean that's good because that means you're doing physics, and that's what I love.
You wanna party with the car?
Listen right now. You have to get your data today or you need to come in during Liberty time. I'm not going to give you a bunch of time, but I do need to make sure that you understand this content because, as you may have heard me say a bunch of times, right, this stuff is the physics that I want you to understand, right? This stuff that we're doing, this analysis, is what I really want you to understand. When you take your AP exam, they're not going to give you an apparatus and say, go take data. I mean, that would be a really great kind of exam, but that's not what the College Board is planned for. They're going to give you some data and say, go. I want to make sure that you feel okay about that. All right? I will also say that this problem is very complicated relative to what I would expect to see on an exam, but it's better to do something hard now with your friends around you than to do something easy now and then get something hard on an exam, right? That's my thought process, which is why we're doing it this way. So I said to you yesterday that I want you to, that the task at hand is for you to graph something on the y versus something on the x where you get a straight line. And some of you got there or were getting there, something like that. But the thing that I may not have said clearly enough yesterday is that what I'm hoping is that you collect some data, both some independent data and some dependent data, and then a whole bunch of constants. And my goal for you is to graph your data such that you get a straight line and that slope number means something. And it might be disgusting. The way I have it written down, it's disgusting. It's a jumble of constants. But the thing is that if I take all of those constants that I measured and I multiply and divide and whatever, square them and whatever, I'm going to get a number that hopefully matches my slope. Do you understand what I'm saying? Okay? That's the goal. And I may or may not have articulated that super clearly yesterday, so I apologize if that didn't make sense. I'm going to give you a push in the right direction because I want you to get it, but I don't want to tell you what it is because I don't think that doesn't get you very far in life. So I'm going to draw myself a picture. And if you, when you were doing your analysis, didn't draw a picture, I would recommend that you do. So there's the T-bar with your little masses over here. And we called these masses, were they mass 2? Yes. Is that what we said? Okay. And for some of you, that's your independent variable. For 2/3 of you, that's just a constant, right? For another third of you, this distance here, what I'm going to call R2, because it's next to the mass 2, and that just made sense in my head. For some of you, this is your independent variable, right? Okay. For others of you, that's a constant. And then you've got that string that's wrapped around, and it goes over here, and it hangs off a pulley where there's a weight, and this one we called mass 1. Okay. And that's the third variable. So for all of you, these three variables matter. You're changing one and keeping two constant, but it depends on which group you're in, which one's which. Okay. The task or the lab said that you want to find a relationship between angular acceleration and whatever that independent variable was. So that's either mass or radius or mass. So we need something eventually that looks like y equals mx plus b that relates alpha and that stuff. Often if I'm stuck and I don't know what to do, what am I going to start by doing maybe? Free body diagram. Now there's not a lot of free body diagramming to do. I mean, this thing is rotating, the crossbar thing is rotating, but that's kind of all just happening because of this string, right? And that string is really being pulled just because of this mass. So this is really where it all is driven from. What forces are acting on mass 1? The Earth? Which way is that one going? Okay. Anything else acting? Tension, right? And the tension is going up. And I will be honest with you, the very first time that I ever did this lab, I did it at a summer institute where they, teach people how to teach AP physics. And we did this lab, and it was like, whoa, this is so great. And when we first did the analysis, when we were doing this, we were talking about the mass 1 is accelerating, right? And we want to find the relationship between acceleration and stuff. And we just said, oh, well, the only thing acting is FG. And then we were like, And we watched that mass fall. And the question that I'm going to ask you is that the only thing that's acting on it? No. And what evidence do you have of that? That's right. It's not falling at 9.81 meters per second squared. That would be really fast. That would make stuff, but no, there's something pulling back, right? Because this has got that rotational inertia stuff. Oh, yeah. Okay. So we can talk about this. So I didn't finish here. This is the rope on M1 FT. And so then we can write an F-net equation, right? I think that would look like F-net for mass 1 is equal to Ft plus Fg equals M1 times acceleration. Do all of these have the same direction? Rudy is shaking his head with gusto. Can I say that? Is that allowed? Sure. Which one's not? One of these things is not like the others. Which one's not? FG? Which way is it accelerating, friends? It's going down, right? This is interesting. It's different. This is why we like to do this stuff. Changes our view on things. FG and MA are both going down. FT is going up. So you can make either one negative. I'm going to go ahead and call FG and MA both negative because otherwise I'll get really confused. Okay? But we can say then that FT is equal to FG. Oops, that should be a minus. Okay. And I'm just going to leave that right there. I'm going to throw one more thing at you. Because right now, the only variable that we have dealt with at all, well, I guess we've dealt with A, because A is kind of like alpha. How are A and alpha related?
Times the radius.
There's a radius in there, right? Yeah, so we can just like sneak in a little secret here that A is equal to alpha times R. What R? This one? No. Which radius?
The other one.
The little radius, right? Maybe we'll call that like R1. This little radius there is so cute. R1, yeah. I don't know why I'm making weird noises. I apologize. That was strange. Okay. So now we've got alpha in here and we've got M1. But that's only 2 of the 4 things we care about. We need to get M2 and R2 in the story. How might we do that? Do what? Do a torque net equation? For sure. Let's do it. Let's do it. Whoa, that's a really funny tau. I apologize for that. Come on, thing. What? It's tau. Capital tau. Or no, sorry, small tau. Yeah. Torque net. Is the system accelerating?
Yes.
Yeah, it is. This is kind of the first one we've really talked about. We've got acceleration happening, which means that we know the torque net has to equal I alpha, yeah? We wrote that down a while ago. We said, this is when we had those 2 columns, and we said alpha, or A is equal to F net over M, and alpha is equal to torque net over I, where I is the moment of inertia, yeah. Okay? It's got the moment of inertia times alpha. And we also know that any net torque is equal to a force times a radius, right? What force is causing this net torque, friends? By that I mean, what is causing this thing to rotate? The tension, right? And the tension here and the tension here are the same. Because it's just a string. A string just transfers force. So that's Ft as well. And if we look at that from a kind of above view, if this is my little tiny tube that I'm looking at, then I've got my string that's applying that tension force some distance away, R1 from the center. Does that make sense? So this is like the above view. So this force is pulling on that thing to make it accelerate. That's the net torque. The tension force times that initial radius. Okay? So, I'm going to stop talking at you. I'm going to put a box around this, a little box around this one, a box around this, and remind you that M2 and R2 live inside here. Okay? I'm going to let you smash some stuff together and see what happens. All right? I want to see if you can do it. I know you can. Work together. Talk to your group. Don't just ask another group what the answer is, because that is not going to get you anywhere in life, right? Struggle through it, friends. You got this.
The radius